Hello everyone. In this video we are going to talk about this inequality. This inequality is very tricky and it may come in some competitive exams, written competitive exams. So what is special about this inequality? Actually, if you want to calculate this integral, then it will be slightly difficult. But here we will use some tricks to actually find these upper and lower limits. Here to solve this integral, actually we will make use of the mean value theorems. Mean value theorems are some theorems in mathematical analysis or in short analysis, and we will make use of those theorems. We will see later in the video that what are the actual theorems here we are talking about. Now the integration is this: 0 to half square root 1 minus x over 1 plus x. So this is the integrand, and we can multiply this integrand by square root of 1 minus x in the numerator and in the denominator also. What we get is just 1 minus x by 1 or square root of 1 minus x square. Okay, so we remember this, and now call it j. This is the original integral. Okay, so this is the original integral, call it j. Okay, and what is this? We have seen this is exactly equal to 1 minus x over square root of 1 minus x square. So this j is exactly equal to this. Okay, so now we call fx to be 1 over square root of 1 minus x square. Okay, and gx equal to 1 minus x. So what is this integrand? This is exactly fx. This is exactly fx gx. Okay, so then j is 0 to half fx gx. That's all. Now we shall talk about the mean value theorem. Mean value theorem says, suppose f is a continuous function on some compact interval ab to r, then actually this integration, the value of this integration a to b fx dx is exactly equal to b minus a times fc. What is c? For some c in ab. Okay, so there exists some c in the open interval ab such that the value of this integral is exactly equal to b minus a times fc. Which particular c we don't know, but there is some c in this interval. Okay, but this is actually a very particular version of the mean value theorem. The general version we are talking about is this. So let f ab to r be a continuous function. Okay, so let ab to r be a continuous function, and suppose g ab to r does not change sign on this interval. Okay, so either g is positive or g is negative, then actually a to b fx gx dx is fc times a to b gx dx. What is c? So there is some c in the open interval ab. So how this theorem the first MVT is a particular case of this general version, you can just plug gx equal to 1 in. Okay, so put gx equal to 1 and you will find the previous MVT. Okay, so this is the general function, and actually we shall use this general version. Okay, so our original integration is this: j equal to 0 to half fx gx. We know what are fx gx because we have talked about them. And this by the general mean value theorem, this is fc equal to, sorry, this is equal to fc 0 to half gx dx. Okay, okay, but what is c? C is some value between 0 to half. Now fx equal to 1 over square root of 1 minus x square, we remember, and just check that f0 is less than equal to fc and less than equal to f half, where c is in this. So you take any c inside this interval 0 to half, then you can check that f0 is less than equal to fc and less than equal to f half. Actually this is true for any c here. Okay, now multiply this inequality by integration 0 to half gx 0 to half gx dx. So this becomes f0 times 0 to half gx. This is fc times 0 to half gx dx, and f half times 0 to half gx dx. Okay, so we shall go to the next page now. So this is f0, 0 to half gx dx, fc this. Now 0 to half gx dx, if you can calculate, so now first f0 is 1, and then secondly 0 to half gx dx. Gx was 1 over 1 minus x, and therefore 0 to half 1 minus x dx is 3 by 8. One can just calculate it. And f half equal to 2 by root 3. If you put x equal to half in the expression for f, you will get 2 by root 3. You can just check. And therefore actually we get 3 by 8 less than equal to j less than equal to root 3 by 4, the required integral. How? Because this is the inequality we have proved. Now f0 is 1, here f0 is 1, okay, and so this is 1, and 0 to half gx dx we have proved 3 by 8, so this is 3 by 8, okay. And fc times 0 to half gx dx, this is the original integral, which is j, okay, and f half is 2 over root 3, and this is 3 over 8, so 2 over root 3, 3 over 8, root 3 by 4, and therefore we have proved the required inequality, but without actually using any knowledge of integration. This is just simple integration we have done, but otherwise we have not done any integration.